Now we'll see a problem based on Coulomb's inverse square law. Here, two identical small sized masses are suspended using a string of 10 centimeter. Length of the string is 10 centimeter. The mass of this body is 1 milligram. This is equally charged. The two bodies are equally charged and it makes an angle of 7 degree with the vertical. We have to find out the charge on this bodies. Then this is based on Newton's inverse square law, and we have to apply Newton's second law. According to Newton's second law, force is mass into acceleration. Now we will draw a free body diagram. So here this mass, this charge is attracted by this string. So this tension T is the force on the charge due to the string. Now this is the free body diagram, and this tension can be resolved into two components, horizontal component and vertical component. So this tension is acting along this direction, then it can be resolved into two components, T sin theta along the horizontal direction and T cos theta along the vertical direction. Now let us apply Newton's second law, horizontal direction. So here T sin theta is acting along the positive x-axis, so T sin theta I cap. So this is a force acting along the positive x-axis, and here positive there is a repulsion, so electrostatic force is acting along the negative x-axis. So electrostatic force is represented as Fe, then I cap. Since it is along the negative x-axis, minus. So there is no acceleration along the horizontal direction, so it is 0. Acceleration is 0, so net force is 0. So body is in equilibrium, so net force is 0. Then after the rearranging this, you can get like this. T sin theta is, if we take this to the other side, I cap will get cancelled, so T sin theta is Fe. Similarly, you apply Newton's second law in the vertical direction. So here vertical direction, F cos theta in the upward direction, so T cos theta J cap to show it is along the positive y axis. Then mass of the body is acting in the downward direction, so mg, since it is acting in the downward direction, negative sign, so there is no acceleration in the vertical direction, so acceleration is 0. So according to Newton's second law, force is mass into acceleration, so it's 0. After rearranging, you can get T cos theta is mg. Then dividing this equation by this equation, tan theta is equal to Fe by mg, where Fe is k q square by r square. The reason the charge on this is also q, charge on this is also q. Force is directly proportional to the square of the charges and inversely proportional to the square of the distance. The value of this k is 9 into 10 raised to 9. Now we can substitute for this Fe, this in this expression tan theta is equal to, for this Fe we can substitute from this equation, so k q square by r square divided by mg. Then this r, distance between the charge is 2a, this distance is a, so this is 2a, r is equal to 2a. Then applying trigonometry formula, sin theta is opposite side by hypotenuse, we can get r is equal to 2l sin theta. This r is 2l sin theta. Now for this r you substitute 2l sin theta. So after rearranging, you can get an expression for q square. Taking the square root on both sides, you will get an expression for q. Then substitute the values. L, length of the string, 10 centimeter. So 10 into 10 raised to minus 2. So this is 10 raised to minus 2 centimeter to meter. Then sine, this angle is 7. Substitute for this theta also 7. Mass is 1 millimeter, so 1 into 10 raised to minus 3. Then after the calculation, we can get this value. Q is equal to 8.9 into 10 raised to minus 9 coulomb.